Yo, this is Nick, and welcome to A Look in the Lab, where I'll discuss the how and why of different powder coating test methods. Today we'll be discussing crosshatch adhesion testing via ASTM test method D-3359B. So today we're going to talk about adhesion, a very important property of any coating. This test method covers procedures for assessing the adhesion of a coating to metallic substrates by applying and removing pressure-sensitive tape over cuts made in the film. As a quick note, this test method is similar to, though not technically equivalent with, ISO standard 2409. This ASTM standard describes two test methods designated as Method A and Method B, with the main difference being the types of cuts through the coating. Method A is a single X cut, while Method B is a lattice of 6 or 11 cuts made perpendicular to each other to produce a checkerboard pattern. In both methods, pressure-sensitive tape is applied over the cuts and removed. Here in the lab, we typically use Method B, and that's what I'll be describing today. The first step in running this adhesion test is to locate an area of the coating that is flat and free of imperfections, and to make the cuts. There are multi-tip cutting tools designed to perform this test that you can use, but a sufficiently sharp blade or knife will work as well, so long as it can provide a clean and narrow cut through the coating. The exact parameters for these cuts should be in accordance with your customer's specification, but the ASTM standard does provide a guide for how many cuts and how evenly spaced apart each cut should be based on the thickness of the film. Today I'll make 6 parallel cuts roughly 2 millimeters apart and repeat that after rotating the panel 90 degrees, which will give me a grid of 25 squares cut into the film. The next step is to brush away any loose film that may have dislodged during the cutting process, and then to apply pressure-sensitive tape over the lattice of cuts. I like to cut about 5 or 6 inches of tape so that I'm able to apply and remove it a few times without having to reuse a section, although the method only calls for one. I like to be thorough. The adhesive strength of this tape should be agreed upon between the supplier and the customer to reduce any ambiguity in the results. Today I'll be using Intertape LA26. You want to completely cover the area with the cuts, and using your finger or a pencil eraser, press down on all the areas to make sure that there is full contact between the tape and the tested area. After allowing the tape around a minute to rest, but not much longer, you should rapidly remove it by pulling the free end of the tape back over itself at as close to 180 degrees as possible. To ensure nothing is missed, I repeat this tape pull process 2 more times with unused portions of the tape and at different angles over the lattice of cuts, although again, it's not required. Once that is completed, all that remains is to evaluate the degree of coating loss due to lack of adhesion to the substrate. The ASTM method details 6 ratings for degree of coating loss, and the ISO method, they use an inverse numbering system, so always make sure you're aware of which method you are reporting and that your client is expecting. The ASTM standard runs from 5B, 0% of the coating lost, down to 0B, where greater than 65% of the coating has been removed. The ISO standard uses 5 as the worst rating and 0 as the best. The ratings are determined by the percentage of coating removed. As you'll recall, our 6x6 grid produced 25 squares of film, which equates to each fully removed square being around 4% of the coating lost. If you used an 11x11 cut system, you would have 100 squares. So these can be useful for ascertaining the approximate percentage of film removed, although more refined digital analytical methods exist for determining the exact amount of coating lost. Simply compare this amount to the appropriate rating scale for your test method and report the corresponding classification. And remember, don't guess, do a test.
Doobie boobity boo.
A look in the lab.